to our second lesson on functions, lesson 6.2, page 250, where today we're going to represent functions, one, by writing some equations. We call those function rules with two variables. Two, we're going to write them with input and output tables. We sometimes call those function tables. And three, we're going to represent functions using graphs. Ladies and gentlemen, how can you represent functions in different ways? And I think I just told you three of them. We've already learned one. We'll talk about that later on in the video, but we learned one in our first lesson already. So ladies and gentlemen, let's get busy. You had some notes to take from the top of page 250 on functions as equations. So let's talk about it. Please remember, you look and listen first, put your pencils and pens down, and then copy your notes after we finish with this slide. I may put some things in here that you want to add to your notes. So very important to actively listen to what's being said as you're watching what's going on. Ladies and gentlemen, so from the top of page 250, it said a function rule is an equation that describes the relationship between the inputs. Those are the independent variables. Remember, inputs, those are our x variable. These are our x variable, and they are independent. That's the independent variable. The relationship between those inputs and the outputs, which are the dependent variables. Remember y. Y is the output, and they are the dependent variables in a function rule. So if you look at the function rule that it states here for this particular function, it wrote the equation y equals 3x. Well, it says our input is -2. So if our output y is equal to 3 times x, and we plug that in and we say y is equal to 3 times a -2, well, 3 times a -2, y equals -6. And voila, we have -6 on their output. So that's how the function rule works. So we're going to practice writing some of those function rules from some words. Go ahead and write this down and then join us on our next slide. So here we have it. We're going to write some function rules from the given verbal phrases. It says the output is 8 more than the input. Well, we know the output is y. Y is our output, is our dependent variable. Is represented by the mathematical sign equals. 8 more than. Well, let's see. 8 more than. If I were to mark my text, 8 more than something. How do I represent 8 more than something? That's right, I'm adding 8. It's 8 more than the input, and the input is always our variable y. I'm sorry, hello. Our input is always the variable x. So here we have y is equal to 8 more than x. So here's our input plus 8. Y is equal to x plus 8. That is our function rule, which is written as an equation to represent this function. Moving right along. The output is 4 times the input. Again, I apologize on that last one. I didn't pause and let you have a chance to write it down. So important to look and listen and then write down. And sometimes I get carried away. All right, the output is 4 times the input. Always good to mark text. So again, our output is y. Is the equal sign. Equals 4 times. Okay, so up 4 times. So 4 times the input x. And of course, there's lots of ways to represent that multiplication. Proximity, the coefficient next to the variable. So we're going to say y equals 4 times x. So y equals 4x. That's pretty straightforward right there, ladies and gentlemen. That's 4 times x. 4 times the input. Oh, go ahead and write that down and join us on our next slide. Our next one, the output is 3 less than twice the input. Okay, so again, we're going to mark our text. The output, we know our output is y. Is always represents the equal sign. 3 less than. So how do I represent 3 less than something? 3 less than twice the input. How do I represent that? That's correct. We're going to subtract 3 from twice the input. Well, how do I represent twice the input? Well, that's going to be 2x, twice the input. So I can write my final function rule. Y is 3 less than twice the input. So 2x minus 3. Remember, if I want to subtract that 3 from here, I got to move it there to show that it's less than that value of 2 or twice times the input. Outstanding. Now, some of you might want to ask, could I write that y equals negative 3 plus 2x? And the answer to that question is yes, that is an acceptable way to write that because that 2x term is positive. So I could put a plus sign between there because I can add in any order. However, you want to get in the habit of writing it the way it's said, plus this is a function rule that it becomes very helpful later on when we get to unit number 4. You'll understand that greatly when we get there. So I'm going to pound on you. I'm going to pound on you about writing your inputs like this. Your function rules like this, using the input term first in our rule. One more time, the output is the square of the input. So our output is the square of the input. So the square of the input, how would I represent that? X squared. So y equals x, oops, I used the wrong color on that. Y equals x squared. I like to get my colors coordinated. All righty. One of these days I am going to be absolutely perfect and no one's going to ever notice any mistakes I make. When that day happens, I'm going to retire because I don't want to ever go back. All right, so ladies and gentlemen, that's how we write our function rules from a verbal phrase. When you come back, we're going to show how to represent in other ways besides a function rule. And, we're not done yet. Hello, we're not done yet. I'm already getting ahead of myself. Ladies and gentlemen, it's so fun working with you. I'll tell you, again, I'm going to be perfect one of these days. So it says you set up a hot chocolate stand at a football game. The cost of your supplies is $75. You charge 50 cents for each cup of hot chocolate. A says write a function that represents the profit P for selling C cups of hot chocolate. So the first thing we got to talk about this function. We're going to write a function, so that's our function rule. Our function is the rule. And what does our rule look like? It looks like an equation. And then it says that represents the profit for selling C cups. All right, well, we got to decide which one of those is profit or the number of cups, the dependent or the independent. Which one is which? So you have to decide. Is the profit dependent on the number of cups? So does profit depend on the number of cups of chocolate sold? Or does the number of cups sold depend on the profit? Well, you're absolutely correct in the first way. The first way is correct. The profit is dependent on the number of cups. So P is our dependent variable, and C is our independent. So that means C substitutes for X and P substitutes for Y. So since P substitutes for Y, our equation has to say the profit is equal to, well, we know that we get 50 cents for each one of those cups. We get 50 cents for each one of them. So I'm going to write 0.5 for every single cup sold. And then we have to subtract. You're probably wondering, why am I subtracting the $75? Well, that is because we spent $75 on our supplies. We spent $75 to buy those cups, $75 for the hot chocolate, and $75 for the water, and $75 for the machine. When you add up all those items in our supplies, we spent $75. So we're $75 in the hole. And part B says you will break even. You'll break even when the cost of your supplies is equal to your income. So how many cups of chocolate must you sell to break even? All right. So to break even, we're actually going to solve our equation, our break-even point. 0 has to equal 0.5 times the number of cups minus 75. Our break-even is when the amount of cocoa we sell is equal to the amount of supply. So you're probably wondering, well, why did I put 0 then? Because our profit will be 0 when the amount of cocoa we sell is equal to the supplies that we purchased. So now we solve this like we solve any equation we've ever done before. We add 75 to both sides to isolate the variable, and we get that 75 is equal to 0.5 times the number of cups we got to sell. We're going to divide by 0.5, and it ends up that the number of cups we have to sell is 150. When we sell 150 cups, we will have made 75 bucks. So then 75 will equal the $75 we spent on the supply, which means we've just broken even. So now, ladies and gentlemen, we come to our first quick write of the night. Go ahead and write this down on the left side of your page. Page number 18, writing the function rule for the statement. The output is 8 less than double the input. Ladies and gentlemen, I'm sorry that this first video took so long. When you're done, take a quick break and come back for our second video of the night.